Now let's take a look at the basics of network address translation, or NAT. You'll recall that there are three private address ranges. Those that begin with 10, those that begin with 172, 172.16, up through 172.31 for Class B, and then of course 192.168. Whatever. These private address ranges are being used inside companies in order that address space might be saved out on the internet. These address ranges cannot be used or cannot be publicly used on the public internet for any servers on the public internet. But what they do is they provide a larger range of addresses inside a company while using a limited number of addresses out on the internet because they're running out of addresses out on the public internet. So the company will use one set of addresses internally and then will translate those addresses at the router for the usage on the public internet. So in this particular example, we're using the private address range of 10.1.1.0 for our inside network. The outside network, the range of addresses that we're given is a Class C address of 200.1.1.0 for the network that is actually provided for this particular company. So what happens is in NAT, this NAT router will translate these internal addresses to these external addresses that can be used on the internet. Notice that the router is using what's called a NAT table, where it maps inside local addresses to inside global addresses. Inside refers to the location of the actual device, and local means this will be the address that's used when the packet is local to our network, and the other address would be used globally out on the internet. So we have a server here that's going to send a packet out to a device on the internet. The source address field will contain the inside local address of 10.1.1.1. When that hits the router compares that address to its NAT table, and it translates that address to the 200.1.1.1, the address that can be used out here on the internet. The router takes the 10.1.1 out of the source field and replaces it with the global address of 200.1.1.1 for usage out on the internet, so that now when the packet is sent out on the internet, that will be the source address that's located here. When the device out here out on the internet sends back a reply, the destination field will contain this 200.1.1.1 address, and that 200.1.1.1 address will be seen by the router and compared to the NAT table once again and translated back to the 10.1.1.1 for local usage inside our network. So that's the basics of NAT operation.